Hi all, this is about rational functions and inequalities. So what are rational functions? So the question is, what are rational functions? So rational functions are written in the form y equals p of x over q of x. The main question we're going to answer here is how to sketch a graph for a given rational function. And to answer this kind of question, these are the procedures. First, we're gonna find the domain of the given function. Then we're gonna find the intercepts. Then asymptotes. And what we call particular points as needed. And we put all that together to get the graph. So first, let's learn how to find domain of given functions. So how to find domain. Domain has to deal with x values. So basically, what are the x values that you are allowed to use within a given function, and which values you are not allowed to use. So if we look at an example such as y equals x over x plus 2, what would be the domain here? It means what are the values you're not allowed to use and which ones are you allowed to use? Well, in this case, we're not allowed to divide by 0, so we make sure that the denominator is not 0. If you subtract 2 on both sides, you get x cannot equal to negative 2. So what we need to know here is that domain for this is going to be all real numbers except negative 2. All real numbers except negative 2. We can look at another example. Let's say x plus 11 over x squared minus 9. What would be the domain here? Same procedure here, that x squared minus 9 cannot equal to 0. X minus 3 times x plus 3 cannot equal to 0. So x cannot equal 3 and x cannot equal negative 3. So the domain is all real numbers except 3 and negative 3. We can look at more examples, say x plus 3 over x squared plus x. What can be the domain for this? Well, same thing, x squared plus x cannot be 0. Factor x out, x plus 1 cannot be 0. So x cannot be 0 and x cannot be negative 1. So domain is all real numbers except 0. And negative 1. Next one, if you have something like this, what would be the domain? Well, we make sure that the denominator is not 0, so x is not 0. So domain, all real numbers except 0. What about another example? Y equals x plus 11 over x squared plus 1. We're going to say x squared plus 1 is not 0. But notice we can't factor this one. So this one will never be 0. This quantity here, x squared plus 1, will never be 0. So this means the domain is going to be all real numbers. So we can use any value of x we would like to use. That's about the domain. Now asymptotes. There are 3 kinds of asymptotes. Vertical asymptotes, we call them VAs. horizontal asymptotes, we abbreviated as HA, and we got the slant asymptote, SA. The question is, how do we find them out? First, with the vertical asymptotes. Vertical asymptotes can be found by setting the denominator 0. And then solve for the x values. Whatever x values we get, if possible, or if any, then those will be considered the vertical asymptotes. For example, let's say x plus 1 over x minus 3. To find the vertical asymptote for this, we set x minus 3 equals to 0, so x equals 3 is a vertical asymptote. So this function has only one vertical asymptote. A function may have no vertical asymptotes, 1, 2, 3, it depends on the function. What about something like this, 1 over x plus 1 over x squared? Same thing, x squared is 0, so x is 0. So this means only x is 0 is a vertical asymptote. X plus 1 over x squared plus 7x plus 12. So what do we do with this one? The same thing. We set the denominator equal to 0. We factor x plus 3, x plus 4 equals to 0. So we get x equals negative 3 and x equals negative 4 are vertical asymptotes. What about y equals x plus 3 over x squared plus 9? This one would never be 0. This would never equal to 0. It's always bigger than 0. So this means this function has no vertical asymptotes. How do we deal with the other asymptotes, the horizontal and the slant? So let's call it other asymptotes. Rational functions will be given in the form axn plus bxm plus or minus something else. So the cases we have, if the degree of the top is less than the degree of the bottom one. In other words, if n less than m, then always y equals 0 is a horizontal asymptote. If n equals m, like degree of the top equals the degree of the bottom, here was less, then y equals a over b is a horizontal asymptote. And note something, when there is a horizontal asymptote, no slant asymptote. So here, no slant asymptote. What about if the top is bigger? So if n is bigger than m, then no horizontal asymptote. There is a slant asymptote. And how do we find the slant asymptote? We use long division to find its equation. Let's look at an example. Y equals x over x squared plus 4. This one, if we look at the degree of the top, degree of x is 1. It's 1. And the degree of the denominator, x squared plus 4, is 2. So notice the top is less than the bottom. So the degree of the x is less than the degree of x squared plus 4. So that tells us that tells us y equals 0 is automatically horizontal asymptote. No slant. Automatically means no slant. What about another example? 3x plus 7 over 2x minus 1. Well, again, y equals, notice how the degrees are the same, so that means 3 over 2 is a horizontal asymptote. No slant. So why does that work this way? That we get only these coefficients 3 over 2 to be a horizontal asymptote. It's always true that if we want to or if we find if the limit of a function as x approaches plus or minus infinity equals a, then y equals a is a horizontal asymptote. Y equals a is a horizontal asymptote. So what does that mean? This means as we travel, if you have a horizontal asymptote like this, y equals a. So what this is saying, if a graph goes this way, as we travel, as x goes to positive infinity, and the graph is approaching y equals a, automatically y equals a is a horizontal asymptote. Same way with x approaches negative infinity. Now to see why this works for the previous example, that was 3x plus 7 over 2x minus 1, we try to find the limit of this as x approaches plus or minus infinity. And to find the limit here, we divide top and bottom by the highest exponent, which is x. So 3x over x, 7 over x, 2x over x, minus 1 over x. And what does that give us? Limit as x goes to plus or minus infinity, 3 minus or plus 7 over x, 2 minus 1 over x. A number over infinity is 0, so this will go to 0 and this is 0. That's why we get 3 over 2. This will be more important later on when you go to calculus. You will learn more about this, why this works. For the meantime, just a quick idea about what we are doing. If we try to look at a different example, say y equals x squared over x minus 1, and the question is, how do we find the asymptotes for this? The first thing is the denominator equals 0, so x equals 1 is a vertical asymptote. X equals 1 vertical asymptote. And now notice the degree of the top, degree of x squared, is bigger than the degree of the bottom one. So this means there's a slant asymptote. There's a slant asymptote. And how do we get the slant? Remember, we said using long division, as we did in previous sections. So you take x squared and divide it by x minus 1. So what times the first x gives me x squared is x, and multiply x by x is x squared, x by 1 is x. Then switch the signs and add, so that gives me an x here. I can still do more work, add a 1, 1 times x is x minus 1, switch the signs, and that leaves a remainder of 1. Whatever we get on the top, the quotient, that's going to be our slant asymptote. And so no horizontal asymptote. If there's slant, no horizontal, and vice versa. Let's do the same thing. Let's do the same thing for y equals x squared plus x plus 1 divided by x plus 2. Again, it's easy to find the vertical asymptote by setting the denominator 0. X equals -2 is the vertical asymptote. How do we find the slant? We do long division. X squared plus x plus 1 divided by x plus 2. So we have an x here. X times x is x squared. 2 times x is 2x. Switch the signs and add. You get a -x plus 1. Then minus 1. Minus x minus 2. Switch the signs and add. So whatever we get on the top, x minus 1 is slant asymptote. So no horizontal asymptote. Now we're going to take whatever we learned and then we're going to graph y equals 1 over x squared minus 4. Okay, so the first thing is domain. Domain tells us where the graph is going to fall and where it's not going to fall. So we take the denominator not 0. Factor. Then x cannot be 2 and x cannot be -2. So the domain is going to be all real numbers except 2 and -2. And these two numbers we just got, those are actually the vertical asymptotes. So for asymptotes, x equals 2 and -2. Vertical asymptotes. Note the degree of the top is less than the degree of the denominator. So that tells us that y equals 0 is a horizontal asymptote, and hence no slant. No slant. Then we find the intercepts. Intercepts. So in the intercepts, what do we have in the intercepts? We find the x and the y intercept. That's what intercepts are. So to find the x-intercept or the y-intercept first, we set x equals 0 in the original function. You get 1 over 0 squared minus 4. 1 over 0 minus 4. 1 over -4 or -1/4. So that gives us 0 comma -1/4. If you set y 0, you're going to get 1 over x squared minus 4 is 0. But if you cross multiply, that's going to give us 1 equals 0. Not possible. So this tells us no x-intercepts, only y-intercept. Now with all the information that we have so far about this function, we try to sketch the graph. We had x equals 2 as a vertical line, the vertical asymptote. X equals -2 as another vertical asymptote. And we had y equals 0 is a horizontal asymptote. And we got 0 -1/4 is the y-intercept. What else we had? So domain, asymptotes, intercepts. So we need more points. Those are called the particular points. So on the left of x equals -1, we try to find some points here. Maybe I want to pick -3. When we pick -3, let me rewrite the function. When x is -3, let's see what happens to the function. 1 over -3 squared minus 4. 9 minus 4. 1/5. So that would be somewhere here. Now asymptotes means it's the line that graph is going to approach, not touch or cross. Only in very few cases that happens to the slant or the horizontal, but not the vertical. So that point by itself, it tells me, and I assure you if you take -4, it's going to be a point lower here. That tells us the graph is gonna go like this as the first branch, we call it. And that's the one on the left of x equals -2. Let's see what happened between the x equals -2 and x equals 2. We can take like a point -1 and we can take 1 and see what happens. When x is -1, y would be 1 over -1 squared minus 4. That's a 1 over 1 minus 4, which is -1/3. If we take x equals 1, y would be 1 over 1 squared minus 4. That's 1 over 1 minus 4, also -1/3. So that means it's going to be somewhere here and another point somewhere there. Actually, wait, isn't that less than the other point? What was the other point? The y-intercept. It was 0, -4. Okay, so that -1/3 is lower. It's a little bit lower. A little bit lower. So that tells us it's going to go this way and this way. And the only thing left is on the right side. What happened on the right side? When you take x equals 3, what do you get? Y equals 1 over 3 squared minus 4. That's also 1/5. So that's going to be here. So that's going to go like that. Several things to note here. The first one, if we have one vertical asymptote, we're going to have 2 branches. If we have 2 vertical asymptotes, we get 3 branches, as you see, 3 of them. So the number of branches that we drew here is 1 more than the number of the vertical asymptotes. The next thing to note, this function call it f of x is even function. Why is it even? Since if you find f of -x equals 1 over x squared minus 4, that's the function itself, and we defined in previous sections if f of -x equals f of x, then that's an even function. Even means there's symmetry about the y-axis. So if when I drew the curve on the left side, that will be the same as the one on the right side. Or to the left of 0, between 0 and -2 is the same as 0 and 2, just a mirror. The y-axis is the mirror. So keep that in mind. Sometimes people use it to help them save work on when it comes to sketching graphs for rational functions. Let's look at another example. X squared over x squared minus 9. Of course, you can find the domain first. X squared minus 9 cannot be 0. X minus 3, x plus 3 cannot be 0. X cannot be 3, and x cannot be -3. So domain is all real numbers except 3 and -3. And those are, as I said before, are the vertical asymptotes. So we got x equals 3 and x equals -3 are vertical asymptotes. Also, we have to look at, see the degrees are the same. So 1 over 1, y equals 1 over 1 is a horizontal asymptote, so no slant. After asymptotes, we find intercepts for the function that I'm gonna write again one more time. If we set x equals 0, y will be 0 squared over 0 squared minus 9. 0 over -9 is 0. If y is 0, then you get x squared over x squared minus 9 is 0. So x squared is 0. X is 0. So we get the same point. The origin is both the x and the y intercepts. And now try to sketch the graph. we had x equals 3 and negative 3, which is similar to the previous example. And y equals 1 was the horizontal asymptote. So we drew the vertical asymptotes, the horizontal asymptotes, and we have 0, 0 as intercept. Now we can select a testing point, say negative 4. Substitute it in when x is negative 4. Y is negative 4 squared over negative 4 squared minus 9. 16 minus 9, 16 over 7. So 16 over 7, 2 point something. So maybe 2 is here, somewhere there. And then if you take negative 5 and check it out, it's going to be here. So it's going to go like this. And then if you try picking x equals 1 and negative 1, you're going to find points somewhere here. So it's going to go this way. Note how this is an even function again, so by symmetry you just copy the one on the left side to the right side. Same graph. That's about rational functions. How about inequalities? So we have solving some inequalities. So they ask us sometimes to solve inequalities such as x minus 1 over x plus 3 less than or equal to 0. How do we do that? Well, first make sure this is 0 here. What makes the top one? What makes the top 0 is 1. What makes the denominator 0? Negative 3. And now we pick testing points. You can pick any value here, say x equals 2. Substitute it in. 2 minus 1 is 1, and 2 plus 3 is 5. That's a positive. So any value you pick above 1 is going to give you always a positive value. What about the next one? Something between negative 3 and 1. Say x equals 0. If you put 0 in, 0 minus 1 over 0 plus 3. That's a negative value. So that region is a negative region. If you pick x equals negative 4, that's a positive region. So the question is asking, when is this less than or equal 0? Well, it's here, somewhere here. So the interval notation for this, it's from negative 3 to 1. Since it's less than or equal, we should use brackets. But we have to be careful here. When using a bracket, the denominator cannot be 0. So negative 3 cannot be chosen here. So that's why we change this to parentheses to exclude negative 3 from the solutions. So negative 3 cannot be a solution. What about one more example? X squared minus 6x plus 8 divided by x plus 1. We're going to see how to solve inequality like this. To do that, the first thing I try to factor the numerator. X minus 4, x minus 2. Now we have 3 factors, so we expect 3 values on the number line. One of them is negative 1, one of them is 2, one of them is 4. And now we run some testing values. So before we do the testing values on any number line, keep in mind there's always negative infinity here, positive infinity on that side. So if I'm going to run like x equals 5, what do we get for that? X equals 5. So to substitute the 5 in, when you substitute the 5 in, you're going to get 5 minus 4, that's a positive value. 5 minus 2, that's a positive. 5 plus 1, that's a positive. All of them are positive values. If you pick x equals 3, you're going to get negative for the first one and positive for the others, so that's a negative. If you pick x equals 0, that would be negative, negative, that's a positive, over positive. Pick x equals negative 2. That would be negative, negative, and negative. So 3 negatives, they become positive and negative. The question, when is this positive? Well, it's going to be here and here. So it's going to be negative 1 to 2, parentheses, because it's only bigger than, And then also from 4 to infinity, parentheses, parentheses, and we use the union sign to combine the two solutions. So the solution would be from negative 1 to 2, union 4 to infinity. That's the interval notation. How about if we are asked to solve 3 minus x over x squared minus x bigger than or equal to 0? So here we factor the denominator. After factoring, we use the number line. What values go on the number line? The top one, x equals 3, denominator 0 or 1. Now we run some testing values. In this region, we can pick x equals 4. What do we get? 3 minus 4 over 4 times 4 minus 1. It's a negative and the bottom positive, so that's a negative. If we pick x equals 2, negative on the top, no, positive on the top, positive in the denominator, that's a positive. If you pick any value here, that would be negative. The same thing here would be positive. So the question is asking, when is this bigger than or equal to 0? So that would be here and here. When we write the solutions down, negative infinity to 0. Now at infinity or negative infinity, we never put a bracket. It's always parentheses. Now for this one, because it's or equal, we're supposed to put bracket. But since the 0 is in the denominator, we still keep it as parentheses. Union 1 to 3. 1 will make the denominator 0, so we put a parentheses. 3 will not make the denominator 0, so we put a bracket. So always, to recall this from previous section, negative infinity, infinity, or only less than or only bigger than, we use parentheses. If it's less than or equal, bigger than or equal, we use brackets, except if it's in the denominator, excluding denominator values. Whatever values make the denominator 0, we use parentheses next to them. We don't use brackets. That's the end of this section.